Hello, welcome to question 4 of our physics exam preparation series. In this presentation, we will be interacting with conservation of linear momentum. Have a look. Right, so as we know, the first question introduces the topic that will be assessed extensively in the subsequent question after that. And if you look at 4.1, we are asked to state the principle of the conservation of linear momentum. And this is the statement that is expected from you. In an isolated system, the total linear momentum is conserved. Okay, it's a one-liner, no problem there. You just have to obviously have your keywords in place. It must be an isolated system, not just any system. And the fact that the total linear momentum is conserved. Okay, or you can say it remains constant. So that is straightforward. Let's go to question 4.2.1 and 4.2.2. All right, so 4.2.1, we are asked to calculate the velocity of trolley Y after collision. All right, so before we do that, it's very important to understand the given sketch or the given graph so that we make correct use of the values. So obviously, this is the initial velocity at this time, say 20 seconds, and this is before collision. Okay, so it has been traveling at 8 meters per second for how many seconds? 0.1 seconds. At this point right here, 20.1 seconds, it collides with trolley Y, and this is the duration of the collision. So that is the contact time, which is 0.1 seconds. Okay, so this is during collision. Okay, and obviously from 20.2 and onwards, that is after collision. All right, so we understand the graph and the fact that obviously velocity will decrease at the point of collision from 8 meters per second, and in this case it is decreasing by half all the way to 4 meters per second. Okay, so what do we then need to produce? The equation, of course, of the principle. Mass times velocity plus mass of y times velocity of y initially must be equal to mass x, velocity of x, plus mass of y, velocity of y, in the final or before and after. Okay, we don't want to use the subscripts I and f. Okay, good. So we are given the mass of trolley X to be 1.2 kg, initially traveling at 8, remember before collision, 8 meters per second, plus this will be 0. Okay, we don't even need to substitute there because we are told that trolley Y will be stationary, or is stationary actually, and then after collision, what happens? We have 1.2. What is the velocity then after the collision? 4 meters per second, plus the mass of trolley Y is given as 0.5, and we're looking for its final velocity after the collision. So if you do the mathematics there, you'll see that the final velocity is 9.6 meters per second, right? So let's be careful. We are asked to calculate only the magnitude, not to state the direction, even though velocity is a vector. All right, so we're just going to leave our answer there. Good. Now let us go to 4.2.2. All right, so here we are asked to calculate the average net force that trolley X exerts on trolley Y during collision. All right, so we need to know the contact time. Okay, for how long were these two trolleys in contact, and we have that is 0.1 seconds, and that reminds us of impulse, right, where the net force times the contact time gives us the change in momentum. Okay, so the average force that we're looking for will be determined like this: the mass of trolley X, okay, and by is Vf minus Vi, so that will be 1.2, and Vf is 4 minus 8, okay, and obviously we will divide both sides by 0.1 here, okay, and if you do that we get 48 newtons. Okay, so obviously the direction is not asked here. Even though force is a vector, we are only asked to indicate the magnitude, all right, which is always a positive quantity, and that takes care of 4.2.2. All right, so 4.3 is asking us to talk about the elasticity of the collision, whether it's elastic or inelastic. Of course, this is where we evaluate the sum of the kinetic energies before collision and after collision, and see if they are equal or unequal. All right, and that will help us to pick the right conclusion. All right, so let us do that. The sum of the kinetic energies before collision. Okay, and this will be half mx vx squared plus half my vf vy squared. Okay, so it's before collision. We have 1.28 squared, so that will be 0 because trolley y is initially stationary. Okay, and if you do that, you get 38.40 joules initially. So let us see what we get here. Again, it's half mx vx squared plus half my vy squared, which is half 1.2 plus 4 now, plus half 0.5, and we have the final velocity from the previous question, which is 9.4 square. And if you do that, your answer is 32.64 joules. Sorry, that is 9.6 meters per second square. Okay, are they equal? No. So we see that the sum of the kinetic energies initially is not equal to the sum of the kinetic energies after collision, and therefore the collision is inelastic. Okay, so guys, this takes care of conservation of linear momentum, right? I believe this was helpful and that you have subscribed to the channel and you're sharing the knowledge with your friends, classmates, so that you can all excel in physics. All right, see you in the next video, question 5. All right, what will we be talking about? Find out when you get there.